Today I will be doing an experiment that demonstrates Newton's first law of motion. Newton's first law states, every object continues in its state of rest, or if in uniform motion, in a straight line, unless compelled to change that state by forces impressed on it. On my desk I have a book and a sheet. Both of these objects are at rest. Due to inertia, which is the property of things to resist changes in motion, this book will resist moving. For example, when you're running, the faster you run, the harder it is to make a sharp turn. This is the same when you're in a car and you go at a high speed and you take a turn, you feel as though you're leaning. This is due to inertia. So, the book will stay at rest unless something makes it move. I will be making the sheet move. When I pull the sheet, I'm applying that outside force. Initially, I expected the book to move when I pulled the sheet. This is because there is friction between the book and sheet. But as I will demonstrate, when I pull the book quickly, the book will not move with the sheet. To set this up, I have my sheet that's thin and doesn't have a thick ridge, and I have the heavier the object, the better. And I will show you. What I'm going to do is I'm going to be pulling this sheet, which applies the friction, but due to inertia, the book will resist moving. And this is a part of Newton's first law of motion. When I pulled this sheet, friction acted on the book in the direction of the pull for a very short time. Because of the force, which was so small, this sheet was able to sneak out without making much movement on the book. The book did slightly move, and people often miss this slight movement of the book altogether. We can also apply Newton's second law of motion to this experiment. The part of the law that relates to this experiment states that the acceleration of an object, in our case the book, is directly proportional to the net force acting on the object. So if I was to set this back up again and pull the sheet more slowly, either like this, the book will move slowly as well. Or if I tried pulling it but slowly, the book would move. This is because the book matches the sheet's slow rate of acceleration and moves along with it. When we pull the sheet quickly, the book needs to accelerate at a greater rate to move along with it. So watch again. The sheet moves so quickly and the book was unable to accelerate with it. The force needed to make the book move is greater than the frictional force available, and therefore it lagged behind. Many people also do this experiment. Kids enjoy doing it as a magician's trick with a setting place. I have a cup and bowl, which once again demonstrates Newton's first law of motion as well as second law of motion. The heavier your items, the better. And what you want to do to set this up is have 2 to 3 feet. You can do it with a tablecloth as long as it doesn't have a thick ridge. And you want to make sure you pull downwards and not out. That's the key. And very rapidly. You want a quick snap. So, as you see, there's more friction between the sheet and the plate, and so you were able to see more of a movement between these two. So I applied a force that compelled the object to move, which is also demonstrated in Newton's first law. I will try again. This isn't the easiest experiment to do when you have silverware. And as I said, heavier is better, but with practice you can do it, and any kids can do it as well. Okay, so tablecloth and dishes work as well as a heavy book and a sheet. And remember to make sure you pull downwards to have the book remain at rest. If you move upward at all, it would lift the book, and so therefore it would not remain at rest. And that is my experiment of Newton's first law of motion, and as well as his second law of motion.